Hi friends, now we are going to study about moving coil galvanometer. In this video, we will see what is the basic principle of moving coil galvanometer, how it is constructed, what are the applications of moving coil galvanometer, what are the advantages and disadvantages of moving coil galvanometer. This figure shows a moving coil galvanometer. It just indicates some important parts of that moving coil galvanometer. Pointer, then moving coil, the permanent magnets and jeweled spring, a dial which is on the mirror. The principle behind of moving coil galvanometer is Fleming's left hand rule. Let us see a left hand of a person. The forefinger, middle finger and thumb are stretched mutually perpendicular to each other as shown in figure. If the forefinger represents the magnetic field, that means the direction of the magnetic field, and the middle finger represents the direction of the current, then the thumb represents the direction of force. Listen friends, for left hand rule, initially you have to tell about forefinger and middle finger, then finally you have to represent the thumb finger. It is very important. Let us see some basic points to remember. To know the direction of magnetic field, see this bar magnet, the lines of force, that is the magnetic field, just moves from north pole to south pole. For the whole volume of magnet, we can see the magnetic field as shown in figure. So, the magnetic field moves from north to south. To know the direction of current, see the circuit. Now, the circuit is opened, that is switch is now off position. Now, the circuit is on, because the key is inserted, the circuit is closed. So, the current is moving from positive terminal to negative terminal. So, when you just cross the bulb is glowing. So, from this experiment, what do you learn? That is, the current moves from positive terminal to negative terminal. Let us see the construction of moving coil galvanometer. To get the magnetic field, the permanent magnets are needed. You see, a north pole is placed on left hand side and south pole on right hand side. The poles are internally curved. Moving coil is wound around a frame. The ends of the coil is to be connected with DC voltage. A soft iron is placed at the center of moving coil. If we place a soft iron in between the magnets, it will produce a radial magnetic field. So, it is not affected by any external magnetic field. So, this diagram represents the radial magnetic field. The middle circle is soft iron. Next, a spindle is running through a center of soft iron. A jewel spring is attached on the bottom side and also the top side of that soft iron, which is used to control the torque. The pointer is fixed at the junction of moving coil and spindle. It can slide over a graduated scale. The ends of the coil are connected with wires for DC voltage. For DC voltage, a 1.5 cell is connected. The current is moving from positive terminal of that cell to negative terminal of the cell. Now, let us see how it is working. The direction of magnetic field of permanent magnet is north to south pole. It is indicated as purple arrow marks from north pole to south pole. When the switch is off, no current flow through the circuit and coil generated no magnetic field. Hence, the pointer stays at 0. When the switch is on, that means battery is connected and the current creates a temporary magnetic field. When it reaches the side A and B, it cuts the magnetic field in 90 degree. According to Fleming's left hand rule, the side AB has experienced a force which is moving towards the observer. When it reaches the side CD, it cuts magnetic field in 90 degree. According to Fleming's left hand rule, the side CD has experienced a force which moving towards the screen. That means the opposite to the direction of the observer. Hence, it constitutes a couple, so that the coil is rotated from left hand side to right hand side. Let us see the recap of the animation. Next, we will see about the theory of moving coil galvanometer. What is torque? Torque is nothing but one of the force into perpendicular distance between the two forces. So, torque can be notified by the letter tau. So, look at the diagram. So, coil just experience having two forces in the opposite direction. So, the distance between the two forces is B. Use this B value and force value in that equation. We will have BIL for force experienced in the magnetic field. Int the perpendicular distance between the forces is B, BI L into B. Here L into B is nothing but area. So, BIA tau is equal to NBIA. Here N for n number of turns. For n number of turns, the deflecting force or torque is equal to NBIA. Here N is number of turns, B is magnetic field, I is current, A is area of that moving coil. The magnetic torque thus produced causes the coil to rotate and the past preference strip twist. It makes restoring couple. So, restoring couple has C theta value. Here C is couple per unit twist of the suspension wire. Theta is angle of rotation. Under equilibrium condition, deflecting force which is equal to restoring force. Deflecting force, that means torque, we are having the values NBIA. Restoring force is C theta, where C is couple per unit twist of the suspension wire. From that equation we can find I value. I is equal to C theta by NBA. Next, I is equal to C by NBA into theta. Here C is a constant, N is constant, B is constant and A is constant. So, the within the bracket term all are the constants, so that the deflection theta or rotation theta is depending upon only the current. So, I is directly proportional to theta. Let us see sensitivity of moving coil galvanometer. What is sensitivity? The general definition of the sensitivity experienced by moving coil galvanometer is given as the ratio of change in deflection of the galvanometer to the change in current in the coil. It may be written as S is equal to d theta by di. The sensitivity of galvanometer is higher if the instrument shows larger deflection for a small value of current. Current sensitivity means the deflection theta per unit current I is known as current sensitivity. So, I is equal to C by NBA theta. From that equation, theta by I is equal to NBA by C. Sensitivity increases as the value of NBA increases and the value of C decreases. Like that, we can also calculate voltage sensitivity, but not in this video. Let us see advantages and disadvantages of moving coil galvanometer. First, we see advantages. It is a high sensitivity, not easily affected by stray magnetic fields. Why? Because we place a soft iron in between the magnets. So, radial magnetic field is produced. So, the concentration of that magnetic field is only in between the magnet poles and the soft iron. Next advantage is high accuracy and reliability. Then we will see what are the disadvantages of moving coil galvanometer. It can be only used to measure direct current, develops errors due to factors like aging of the instrument, magnets and damage of spring due to mechanical stress. Next, applications of moving coil galvanometer. The galvanometer can be used to measure the value of current in the circuit by connecting it in parallel to low resistance. That means, the galvanometer can be converted into ammeter. How do you convert into ammeter? By connecting a suitable low resistance in parallel, you can measure the current. Next, B, the value of voltage in the circuit by connecting it in series with high resistance. That means, galvanometer can be converted into voltmeter. How do you convert? By connecting a suitable high resistance in series connection with it, we can measure the voltage. Thank you.